Hello friends, today I'm going to solve LeetCode problem number 103 binary tree zigzag level order traversal. In this problem we are given a root of a binary tree and we need to return the zigzag level order traversal of its nodes. Now what's zigzag level order traversal? So basically zigzag means we are going to start from the left from the first level, then the next level we traverse from right to left, and then in the next level we traverse from left to right. So that's the level order traversal. Now let's see how we could solve this problem here. Okay, so let's take this example and paste it here. All right, so we are given the root node 3, right? So how could we solve this problem? Basically this problem could be solved using DFS and BFS as well, but I'm going to use breadth first search for this solution. So now let's start with our BFS solution. So for in case of BFS, what do? We traverse one level before we traverse the next level, right? So that's what we are going to do here. We are going to start from the very first level, that is level 3. So our resulting array initially would be empty. So now we are at our first node. So we traverse from left to right. So while we are traversing, we know that this node is basically at depth equals to 0, right? And since the depth is equals to 0, and what we do is we basically try to take the modulo of 2 so that we know that it's even, because we want to alternate, right? So at what positions do alternations occur? Well, basically alternations occur at every second position, right? Starting from this, alternations occur here. For this, it occurs here, right? So it's in second position 1 and to second position, right? So that's why we are taking the modulo of 2 for the depth. Since the modulus is equals to 0, basically it's even. So what we do now is we push it to our result. Basically we are going to push to our sub result here, that would be result of the level only. So we push our value 3, and now we know that at the end finally we have completed this level, traversal of this level. So what we are going to do is we are going to push this value to our original result, so that would be equals to 3 here. Now next what we do is we traverse the next level, but before we traverse we are going to increment the depth. So now the depth is equals to 1, and since 1 modulo 2 is equals to 1, so we are going to traverse from right to left here. So while we traverse from right to left, in our queue, basically, because we are going to use queue for DFS, for breadth first traversal, right? So how do we create our queue? When we, for this node, we push its left child and then the right child. So we push 9 and 20 to our queue. All right, so far our length is equals to 2. So for our first element in the queue, what do is this element, right? So although we are starting from this element, but we will be traversing from right to left. So how is that going to occur? Basically, let's look here. So this will be the level traversal for our value. So since this value is equals to 1, so we are not going to push, but rather we are going to shift. So shift means this value will go first. So 9 comes first, right? And then what we do is basically we push all of its children to our queue. So since it doesn't have any children, so we are not going to push anything to our queue. And the next element in the queue is 20, right? Now 20, and again the depth is equals to still 1, right? So we basically unshift to our level traversal. So while we unshift, every element is inserted in the first position, 0th position. So what do we get is 20 and 9, that is the traversal from right to left. So this value then we push to our resulting array, which is here, which will be 20, 9, and our queue will have the value 5 and 15 and 7, the two nodes. So now our queue will have the value 15, 7. So what we do is we start from our first node, and since this depth is equals to 2, which is even, so we start, the traversal should be from left to right. So what we do is we traverse, and while we traverse we push into our traversal. Here we performed on shift right, but here we are going to perform the push operation. So that's just the difference. We push 15 into our array, and the next node we push 7. So basically we found our traversal here and we added to our result, so that would be 15, 7, and this will be our final answer. So basically what we are doing is we are checking the depth, and if the depth is even then we push, if the depth is odd then we unshift. All right, so let's start coding. So we first of all will check if the root node is empty. If it's empty, then we're just going to return an empty array, else we are going to create our result array, and depth will be 0 initially, and our queue will have the value root. Now we create our BFS function. So while queue length, while the queue is not empty, we take the size of the queue, and then we also need the level of the queue, right? Level or a traversal. Now for starting from 0 to the size, so we check the depth. If depth modulo of 2 is equals to 0, then we are going to push, right? So level dot push. So we are going to push our, okay, before that we need to we need to get the element. So let node equals to queue dot shift. So this node, we are going to push this node, else we are going to unshift the node, okay, the value of the node. All right, so once this is complete, for the queue of that length size, then what we are going to do is we are going to push our level order traversal to our result. So this will be pushed, and then we are going to increment our depth. Now finally we are going to return our result. Let's run our code. Okay, all right, what's wrong here? Okay, so we also need to push to our queue as well. Okay, so here we are going to push to our queue the left and right node as well. This is for the traversal. Basically for each level we have to complete each level, right? So we are doing that, and this is just to make sure that our traversal is in a zigzag manner, that's all. So only the difference is in this node. To this node, this code will make our result in zigzag manner. Okay, what's wrong again? Okay, yep. All right, so we need to check if the doesn't have any left value, left node or the right node. Because we need to check that we are not making any check here, so that's why we need to check before we push to the queue. So now let's submit our code. Alright, so talking about the time complexity for the solution, we are using a queue, and every time we are pushing our node to the queue, right? So that would be in a for loop, so it would be O of n. Now let's look at this part of this problem, this solution. So we are performing an unshift operations. Unshift operation means we are inserting to the beginning of a array. So while we insert to the beginning, all the other elements in the array should be shifted one step to the right. So what will that create is that would actually not be of one constant, however this would be the based on the length of the array. So that would depend on the size of the level, so the maximum size of the level. Let's suppose the maximum breadth of a level is L, so that would be O of L. So basically our time complexity would be of M times L, and the space complexity, because we are using a queue and the maximum size of the queue could be O of yes, the size could be also based on the depth level of, yeah, this could be maximum of O of n.